Autorización para lanzar MIURA1. Aviónica. Listo. Coordinador de plataforma. Listo. Recibido. Hidráulica y umbilicales. Listo, hidráulica. Listo, umbilicales. Recibido. Recuperación 1 y 2.
Listo, a falta de que recuperación 2 confirme la llegada al punto de espera.
Recibido a espera de llegada de Libertad 6 a punto de espera. Coordinación de rango PLD. Listo. ROC 1 y 2. Recibido ambas. ROC 20, director de lanzamiento a todos los operadores. PLD Space, MIURA1, listo para lanzamiento. 3, 2, 1, T0. Vamos, MIURA. Arranque motor. Tenemos despegue. Tenemos despegue, MIURA1 despegue. Rampa libre. Activo correcto. Temas 30, Atlántico. Propulsión nominal. Entrando en régimen transónico. Trayectoria nominal. Tema subminuto, MIURA1, supersónico. Propulsión nominal. Máxima presión dinámica. MIURA1, máxima presión dinámica. Seguimos, seguimos. MECO, tenemos MECO confirmado. Tenemos experimentos y vemos microgravedad dentro de la cofia. MIURA en el agua, misión finalizada.
Muy buenos días.
Good morning and welcome to the press conference, the presentation of the technical result of our launch campaign with MIURA1. I'm Ezequiel Sanchez, Executive President of the company. I'm joined by Raúl Torres. He's the Director of the Launching and co-founder of PLD Space, and the CBDO, who holds multiple positions. And thank you all for coming here today, those who join us here in the auditorium and all the media that have joined us online. We've seen great interest in the results of this historic milestone that we've achieved, and we still haven't got used to seeing the actual result. I get really emotional when I see the video, because we've made history. We had the feeling that we were developing a project that had a critical impact on a need that we have today in terms of competitiveness in Europe, and position our country as the 10th one with the capacity of launching rockets is a strategic asset in the European realm. This will allow us to become competitive in the space sector and allows us to have certain sovereignty. This has had an effect worldwide. This has gone beyond the domestic scope. In the international media, they have recognized the importance of our achievement. And this is a recognition because it is very difficult to do so. And to do so the first time around, we've conducted 3 attempts. The first one was very dependent on weather, but we did have a first attempt where there was a technical component. We had a second attempt, and then on the third one, we achieved to make a successful launch on the first attempt, and Raul will tell us the details later. We've heard some comments regarding the reuse and recovery of the vehicle. When we talk about success, we say so with full responsibility, with full accountability. Perhaps there have been 6,500 launches in the history of mankind, and only 100 have been recovered. And those companies that have recovered them have started to do so after the 5th or the 10th launch. This is a technology that is clearly within the requirements and from the onset of our project. And this will be very useful for MIURA5, but it wasn't a primary objective, and we will hear about that later. And it is important to be aware of this. Space changes everything, and having this capacity to launch, to make launches, when we talk from the business point of view and the potential that it has, this all requires aligning a series of elements in which Spain had competitive levels that were quite high, but we needed to conquer this last link so as to ensure sovereignty. This is key. And so we would like to start with a list. It will not be a detailed list, but there are 2 institutions that have helped from the onset of this project, and they also feel, as we do as part of the team, the importance of this successful project. That is INTA and SEDETI. They have both helped to make this a success. We have received the support of investors, partners, supply chains, national governments, regional and local governments, whom we also thank. But of course, INTA and SEDETI's role have been critical. And without further ado, we'll give the floor to Raul so that he talks about the main objectives of the technical campaign. Then we will provide a description of the implications from the business point of view, and we will finalize with some points on future projects. Well, first of all, thank you all for coming. We will try and share the results in a simple way, the results that illustrate the success of MIURA1. The idea here is to understand not just that the launch is a launch per se, but is a series of first times. We are the first company in Europe that has launched a rocket successfully. This is a very important achievement. And the first company in Europe to launch the Kerolox engine that combines kerosene and oxygen. This is, well, secondary, but this type of technology is quite complex and had not been developed before. Therefore, this has this epic component as well. It's also the first space launch from continental Europe. And this is so because up until now, all European launches have been made through the French Guiana. But this is the first time we do it here, and there was an added difficulty because we didn't have the structure to do so. We did so at Huelva's Space Center. It is also the first launch of a technological startup. There are other competitors that are doing so in Europe, but we were the first to launch, and it's one of the first pressure-fed rockets that have been launched. This is also critical and implied an additional challenge for MIURA1. First Spanish company, we would say so internally, that has positioned the country with an added capacity. Not many companies can say so. From the development of the flight and the mission, the behavior of all the subsystems worked as expected. We call it nominal behavior, as well as all the operations throughout the flight and after the flight, through the finalization of the mission. And we will talk about that later. This means that we have acquired full technical knowledge on how to create a space launcher. This is something that only few countries in the world can do. It also allows the company to have this technical know-how and about the behavior of subsystems. We've gone from predicting to actually knowing how they behave. And this has been a fundamental leap in the industry. And finally, this brand of being the first private European company to have launching capacities, and the only one in the world. The other two are currently developing launchers. This is important because this means that we also have the support of the government. We have a financial support from the government, but not an operational support. This is something that has appeared in the media quite often, and we've been asked about this. The upper chart shows the trajectory with apogee at 80 kilometers and horizontal distance of 40, and this was the trajectory that we had planned for MIURA1. But before the summer, we had seen that high winds and the safety reviews showed that in case of failure of the launcher, whether for accidental reasons or due to human command, this could create a debris situation in case the rocket would explode, and this would put the rocket outside the security area. That is why we worked hand in hand with INTA to minimize the impact that this could have from the security point of view. Therefore, we decided to go for a second trajectory. If you can see on the upper chart is a lower trajectory that had higher horizontal speed. If we have a football and we kick it to the sky, it can fall on us. But if we kick it forward, it will not fall on us. And up until the very last minute, we wondered which option we should follow. The idea was to maximize security in the closer range, that is the launching platform, the beaches, and kilometers around the beaches. This made us change the height from 80 to 50 and the time that the engine would be on. And we decided to reduce this to 103 seconds. This is a summary of why, instead of going up 80 kilometers, it went to 50 kilometers, and why we changed the trajectory. The expected trajectory was in blue, and the actual trajectory was in red. And as you can see, it was pretty much identical. That means that the trajectory was well calculated and the launcher worked as expected. You can also see in this very interesting chart, on the upper chart, is axial acceleration, that is rocket B, is through the rocket itself. And where we see discontinued marks, what we thought that would happen, and in the continued lines, what happened. This made the acceleration on board higher, didn't mean any problem, but what happened is what was expected to happen. In the end, where there is no acceleration, is 720 meters per second. And here you can see the expected and blue line, the continued line, and then measured, those peaks that you can see there that are the result of acquisition, how we were seeing it in real time. Therefore, we can see that the rocket followed the orders. We can also see that from the point of view of trajectory. It's a bit harder to see because they overlap if we see it from the upper part, and you see it on the image, the takeoff or the liftoff phase, and then if you watch the video again, you hear the word Atlantic. That is the point at which the shadow of the rocket was on the water, on the Atlantic Ocean. Up until this moment, would start gaining this vertical speed. On second 32, the rocket was on the water, and if there was any incident with any of the subsystems, the rocket would fall on the water and not on the ground. It's hard to see because the expected and the actual trajectory overlap. They are pretty much the same. We've done this first data analysis that we will share with the main authorities that participated in the development of MIURA1. In this case, INTA, the authority in charge of the launch. There are many data to be analyzed, but you have the main data, and on our side, we conclude that the launch was a success. While it's true, of course, that there were interesting events that we didn't expect. For example, during the subsonic phase that is below the speed sound, on the videos you can see that the rocket started oscillating and started to fly in that way. If you see the onboard cameras, there were some water drops that started to move. We didn't expect that, and this happened because the behavior of the RCS, that is the command that it prevented from spinning, had much more consumption demands. This is why we think that due to the crosswinds that were from kilometer 1 to 6, this could have affected the rotation on board. We knew that this would happen, but it happened much more strongly than we had anticipated.
We knew that if we were going to reach supersonic speed, two things could happen. Either a larger amplification of that dynamic and we will lose the rocket, or it will disappear. And that's what happened. It reached stability, and until the engine stopped, the behavior was perfect. We reached apogee, and when we reached that, we released a lot of small pictures of the whole team, our children, important family members to us, also 2 badges of Spain's flag, and from the business card that I did in 2008 when we still hadn't begun this. And it was very emotional. Each Spanish citizen was on this rocket, and each member of the team was there too, through a picture, an ID picture. And we also collected all of the data experiments from SARM, and it all came back to Earth. We also brought a piece of cheese, something that we had said many times. We confirmed ahuyenta lobos, wolf scarer, and that's something that relates to what happened to us through these last few years. We had to suffer in the corporate world. Re-entry. We reached apogee, and then the rocket came back. It went into orbit. We have this simulation with a soccer ball. The supersonic phase of re-entry. Something happened that surprised us. The aerodynamic behavior of the vehicle in re-entry was much better than what we expected. We had 40% of uncertainty in our models. This is an estimate. Always happens in the most difficult things from where you can get information. You cannot put anything at supersonic speed unless you actually do it. Very few companies in the world have access to this type of info. Aboard, we had aero brakes, similar to the flaps in a plane, that function in supersonic and subsonic speed. Their behavior was difficult to predict. And even talking with experts, with INTA experts, experts in aerodynamic, tenure professors, they say, we do not know what can happen. This is such a rare thing. You've done such a rare thing that when this reentry is at 2,500 kilometers per hour, anything could happen. What happened was where we estimated they behave even better than what we expected. Through reentry, we compilated aerodynamic data at supersonic and subsonic speed, and they impacted that airflow, to simplify it somehow, when it crashes into the vehicle and how the vehicle warms during re-entry. This is something expected, and we compilated all of the data. This is crucial because it will help us improve aerodynamic models of MIURA-5. It's to improve the efficiency of this launcher when it flies, and it will be much larger, of course. We reached the subsonic speed, the brake phase, and then it was below the speed of sound. Well, the parachute ejected. This is not a picture from that day, obviously, because we launched at night, but this is of the recovery trials that we did before it. We know the parachute ejected and opened properly, and we know that because of two things. First, pyrotechnics. Pyrotechnics worked great. The parachute was ejected. In the second place, because of the acceleration during the brake phase. As when we are driving our car and when we step on the brake and we feel that. That's the acceleration was real. We were able to measure it. The parachute opened and it made MIURA1 brake. Well, here is the water landing. We know we had defined the impact area and the rocket fall within that area. The purple or pink zone, that's the area where we calculated where it could fall, and the blue point is exactly where it fell. We have the exact coordinates for that point, but we believe that the impact was lateral. It didn't fall in the water and then lay down, it fell laterally. So we suspect that one of the fuel tanks broke and some water got inside, but it wasn't when it got into the water. We know that because in the area where it fell and 5 kilometers around, there were no pieces that could float. That means that the rocket fell in one piece and it sank in just one piece. It never broke. It never left anything that could float, not even the parachute. That's good news and bad news. Good news. Our whole prediction was properly done. And we believe it had to do with the lateral winds we had during takeoff. So for 8 hours, we were searching for it with several boats. Also, INTA provided some boats. And, well, we realized the rocket had sunk, and we decided to abort. Well, this was the work of everyone. 70 people from our PLD team participated in control center. You only saw 22, 150 team members, the 22 who were in Huelva, and the rest who were from the control center. And something we like to say is that MIURA-5 will be an even better rocket thanks to our learning process. We transfer over 1,000 improvement points. All these actions will be transmitted into MIURA-5. We were able to validate many prediction models. Now we work with actual flight data and with the improvement of those simulations. And we're able to learn how to launch a rocket. That's very crucial. It's not only developing the launcher from scratch, but to learn how to launch it successfully. From strategic perspective, a better vertical integration of technologies, propellants, structure, and avionics. Our last slide. This is, for the first time, we're showing the first orbital launcher, MIURA-5, for the European private market. It's developing great. Trials will begin at the end of this year. Avionic structure, among others, and 500 kilograms up to 1 ton. depending on whether we're doing polar orbital or equatorial missions. Now we're going to talk about the implications from a business perspective. Thank you so much. Raul's presentation was amazing. I think this is a time, as we say, to celebrate a little bit and then keep working on MIURA 5, which is what we're good at. I would like to talk about things from a different perspective. What does this mean for our company from a business perspective? This is not just an R&D project just for research and development's sake. This is a sustainable project. This launching allowed us to validate many business aspects, not only technology. We're opening a new path towards our customers in this new revolution of the space sector. And I would like to say that one of the things that we have validated is our financial model. When you create a company, you have to estimate what's the cost of each launching and at what cost, at what price can you sell it. So being able to do this has allowed us to validate how much does an engine cost, how much is a logistic, how many people you need. Well, all of these European businesses are doing estimations, but we know what things cost. The demand to buy this type of, let's say, launching service, there are more and more satellite and operators and manufacturers that are needed because there is a scarcity of launching services which our colleagues are trying to develop. Another aspect that we would like to mention again is that this is a technology that offers a fully sustainable project from an environmental perspective. We are developing with Repsol as a national company for energy, biokerosene. Our rockets can be recovered. We can only launch it several times. But with this technology, once it has matured enough, we won't generate junk in orbit or at the sea. Most of our satellites last at most for 4 years of the ones that we are deploying in orbit. All of our factories, our trial banks are done sustainably from the beginning. We use rainwater that we filter, and once it's used, and we give it back to the river. In terms of energy, we are completely aligned with the 2030 agenda regarding sustainability at the European level. We are offering a value proposal for MIURA 5 that is premium. We are not in the scope of low-cost space launchings. We want to offer premium value. One of the biggest milestones of this year, beyond this launching, is that PLD Space, we have trading commercial opportunities for a value of over 320 million euros. Here we have several projects. Unknown are those that we cannot talk about, of course, also have to do with defense. Telecommunications are the driver of our company. We have many customers who want to buy MIURA 5 and who are encouraging us to launch MIURA 5 into the market as soon as possible. Sending rockets to space, work for solving problems on Earth. We'll use space infrastructure without realizing it. If you have ever used internet from a plane, if you use a sports event during the weekend, if you use Google Maps, well, there's a lot of on-Earth infrastructure, like antennas on top of buildings, but there's a lot of space infrastructure that we need to send to space. So our message will be that this milestone, and we would like to thank the technical team. This makes my life easier on the commercial side of the business. If I had a good relationship before, now it's even greater. So we're beginning to close our first binding agreements next year. we will begin to close our launching manifesto for 2025 and 2026.
La empresa
To finalize, I would like to talk to you about the company we're building upon this project. 4 years ago, we were an R+D project, and in 4 years, we will just be a company at scalable operations with our predictable, sustainable, and profitable side of business. We're right in the middle of our journey. We have reached a series of technological milestones. We're moving forward on this mission to focus on the market, and we believe this is the new path we need to develop. We have to identify the demand and follow that demand to provide the right offer to cover that need. This is a new way to access space. It's not to develop a program that when it's finalized, the world has changed and it no longer has the needed commercial capability. We need to identify the market needs and adjust the technological offer to meet those needs. We've done so with fiability,
muchos comentarios, ¿no?, que hemos tenido.
with a level of reliability beyond the industry. This is something we've done over the last 12 years regarding the level of funding of the company, our capacity to fulfill those needs from a technical perspective. We focus on keeping the quality levels that the company needs. The reliability, we think, is going to be what the industry needs, and we're going to finish this project in shorter time spans. We have developed an industry that has many entry costs. It's quite complex. It has cost us 30 million euros. Well, 29.7. We've managed to access launching with a very cost-efficient value. This is good for stakeholders, but also for the development of MIURA5. We can adequate the scenarios we had about how MIURA5 was going to develop and how we could scale to adapt this learning and cost curve. This is key, both the aerospace industry to be able to meet the market needs. We have a team made up of over 150 people, 12 different nationalities. We work from Elche in Alicante, Spain. We are able to attract talent, and we also have facilities in Huelva. We are a company from the regional level, but we can compete at the global level. We feel very happy with the type of company we're building, and I believe one of the crucial competitive aspects is the way in which we think, the way in which we focus on projects. We have so many things on our table. We have so many issues. With the launching, we've solved one of those problems. We have many other problems. We'll solve them all.
And we do so in a context that is very complex. The operators in the sector and the recognition that we have received from them is something that we welcome very much, because they are aware of the difficulties that this bring. There were many barriers to be tackled, and we did so. The technological, the operational, the corporate aspects that Raúl mentioned earlier. But what we are fully convinced of is that we are creating a solid industry. We want to create the benchmark technological company in Europe for the space sector. This is important because we know that this is a complex challenge, but we are in a moment in which we think it is more necessary than ever, and we can contribute with our capabilities to achieve a level of relevance that is at the level of what our clients expect. And just to wrap up, I would like to tell you that MIURA1 is just a beginning. We are convinced of this. We know that what we've done so far is validate the hypothesis on which we created this company, meaning that accessing the space was very complex. We had to divide this task into two parts. First of all, create a commercial demonstrator in order to identify all the areas of improvement. This I think it's a differential headline that we've been able to apply all of this into MIURA 5, and we are very happy. And perhaps there are some messages that I still need to answer, but in any case, we feel very happy to have fulfilled this milestone and having made history in the space race. The space industry works on trial and error, and the possibilities for success are around 45%. We've achieved this the first time around. There are other competitors that have had higher costs and have required more time. So we've been the first, and we have to celebrate this. After the launch, we celebrated for 2 hours, and 10 minutes after, also with the team, we had a breakfast together. But we do need to recognize what we've achieved. That would be all on our side. We thank you for your presence here today, and we remain at your disposal for any question that you may have. If you wish to formulate any questions, we will bring you the microphone. And for those who are watching us through the streaming platform, you can also submit your questions, and we will read them out loud. Hello, good morning. Miguel Ángel Valero from Abierto. I would like to know about competitiveness of Spain after MIURA1. What it would be the ranking now?
Sí, o sea, no te sabría decir, ¿no?
I couldn't tell, really. I believe we have this chance at the segment of small launchers to be in a position of leadership. We have no complex of inferiority. The US is, of course, a leader in launching. And in other places, such as Asia, India is a huge leader, and also Japan. Right now, we have the potential to compete with those countries. I don't know what's our position exactly, but our ambition is to place Spain at the leadership position. We know it's a complex challenge. We believe the hardest part is still ahead of us. We will lack the momentum to reach that as a MIURA.
Hola, buenos días. En primer lugar,
First of all, congratulations on the launch. And I say liftoff because you've mentioned on many occasions the success of this launch, but you haven't talked about this being a suborbital flight, but it is indeed. You haven't reached the space. So the goal is to reach space and market MIURA 5 and reach the space. But I wanted to ask, in any case, what you sent to the media a few days earlier said that you would reach 80 kilometers in height. If it would have reached 78 or 79, that wouldn't have been a big deal. But reaching just half of what was expected, I won't say what I think about it, but I want to ask you, was there a maritime or ground space in terms of security or safety if there was an explosion, for example, something that, of course, didn't happen? But why the change? Why did you decide to change the trajectory and lower it? I don't understand this. And as regards this, did you do so manually, or were there two programs in order to apply one or the other? When did you decide to apply the second alternative, a lower height? Once it was in flight mode, I would like to hear about this. But it was interesting that a few days earlier you talked about it reaching 80 kilometers. Also, on the media, we heard that MIURA 5 would be launched from Teruel in Zaragoza. I would like for you to confirm this. And also, if you could tell us whether there is a second launch of MIURA1 to be expected to confirm that the engines can reach 80 kilometers approximately. Thank you. So 4 questions.
I hope I won't forget any of the many questions. Clearly, MIURA1 was going to do a suborbital flight. It didn't have the capacity to put anything in orbit. This is something that is common knowledge. The height that it can reach is a consequence of the previously defined trajectory and the time during which the engine is working. The engine can work for 120 seconds during flight. It can work for much longer, but you wouldn't have enough fuel on board to make it function. So 122 seconds flight. We can reach 100 kilometers of flight. That's the theory. Now that we have flown and we have this confirmation of models, we know how much we can work with the real flight data that we have. The goal was 80 kilometers for a reason. We knew with the quality sensors interval, with the behavior that we could see, we could meet the 80 kilometers of flight. That's the definition of why we're going to fly up to 80 kilometers. When you do this from static interval to actually flight in Huelva, there are a series of new considerations that we did not have. One of them is the possibility that the rocket can fail. We had been using the atmosphere since February. We had sent aerostatic balloons. We could see how the atmosphere from spring into summer was becoming increasingly worse. At the first launching, we aborted because technology hurt us. Our weather prediction model that we also had to develop, and we have to thank everyone who helped us. This model said that the launching in the morning would slightly improve in the first trial. And what actually happened was the opposite. It worsened. They were outside of our trusted area. According to our trajectory simulation, a rocket could endure with almost 100 kilometers per hour of wind speed. When facing a situation in which we could go wrong with our model, because that model wasn't validated, we decided to abort. After the summer, when we had our prediction model, we haven't flight, so it's only a prediction model. After the summer, the winds are going to improve in Huelva. But instead of between kilometers 10 and 12, we had them between 1 and 6. These are winds within the trust environment for the behavior of the engine and the control of the trajectory, but we still have certain uncertainties. And that model is when we consider whether the trajectory, the safe trajectory we had considered before the summer, is the one we should use, and we should decide on the 80 kilometers one. Up until that moment, everything we had analyzed, all of the flight safety analysis was with the second trajectory, not with the first, because we needed to discard that from February. We realized it was very difficult. But we said, we're not going to do anything to change, because up until the last moment, we can decide whether to chart one trajectory or the other, depending on the balloons that we launch, and can tell us what is the wind profile. So the balloons were giving us the same information as the trajectory prediction. The rocket was going to fly well with lateral winds that are constantly changing the direction, and they were establishing themselves at the worst possible direction for us, which was between September and October. So we thought, if we move forward, everything looks fine. It seems this is going our launch day, but we need to remind again the ghosts of what happened on the first time. Height winds can affect our trajectory regarding safety. But you say you have a huge area to launch. That's the second question. Within the exclusion maritime and land area, if something happens, the rocket drops. But what happens if a fragment of the vehicle, which our prediction model for fragmentation, once you're in a flight, all of these little pieces fly and go everywhere? Well, we trace where each one of them is going to fall. But there is a level of uncertainty if we miss on the model. These fragments can lie outside of the safety area, and we have no competency. We cannot change that predefined area. We have already established a border for our insurance if it wasn't precise enough, only one screw could fall outside of the safety area. It could fall on a person, on a ship, and we could have a really problematic situation. So we decided to do things differently to get as far away possible from the ramp, to be away from the Atlantic. And that last day, that's when we decided to change the trajectory from 80 to 40 kilometers. The engine behavior was excellent. We are very confident on this. We've shown everything. The reality is that the rocket has done what it was supposed to do. We said we were going to fly at 80. Well, we've done what we had to do. That was to guarantee safety.
Regarding the second unit, the possibility of making a second launch, we had expected within the flight campaign the possibility of flying a second unit. We're analyzing data to see if there would be a delta or an additional data analysis. If we have this data validated to know the impact point for the MIURA-5 program, then we would decide whether to make this flight or not. This decision is yet to be made, and we are analyzing within the data analysis whether this would bring an added contribution to this. It is expected to happen by the end of the year, the decision. But it will be impossible to launch MIURA-5 from Teruel. This is impossible to do from neither Teruel nor Huelva. The vision that we had in the first launch is suborbital, and actually there were a number of graphs, but we needed it to be suborbital because we wanted to test re-entry. And I think that the launch, in view of the technicians, has been a clear success. And on a maiden flight, to be able to follow the trajectory as you had expected. The 80 kilometers issue, well, this was something that had to do with figures, but in any case, our team is very proud, and we've received the recognition of many partners, and the rocket did what it was supposed to be made. It was surprising, even for us, to achieve this performance on a maiden flight is amazing. And I would summarize, we've gone for an optimal global instead of local. So globally, if we achieve this 80 kilometers, we would put some other factors at risk. As Raul said, it was a surprise even for us, because funnily enough, what we had just tested the most was how to announce to ITA that they should call the firefighters and that there was an emergency. I dreamt of that. I had nightmares of me calling 911 and explaining ITA what had happened and the activation of the emergency plan. We had an emergency plan implemented. We had all the firefighting staff ready, and nothing happened. We reached Apogee. We thought we were living a dream. It was really difficult to achieve this. This must be said as well. But perhaps it's a beginner's luck. We don't know. But it's no coincidence that this happened the way it did. This is a result of wonderful teamwork, and in the end, we've seen the fruit of our work. Perhaps our second flight won't go as well. The subsonic portion was really demanding, but the engine was able to deal with all the wind problems that we faced, but we wouldn't have imagined that this would be the case. Yes, we will now give the floor to other journalists who also have questions. And perhaps, Juan, we can hold an interview later if you wish to have one. So we have time for 2 more questions. Thank you very much. Good morning. Eduardo Avila, Navas Aviación Digital. 2 things. There is a fundamental element of the rocket, and that is the engine, which was developed internally by you. I understand that the difference with MIURA-5 is that it will carry 5 engines. It will be the same engine that you tested, or will it be different? The second phase engine is more similar to this one in terms of thrust and size, which is something manageable. The first phase is 10 times larger, much more powerful. It's much more complex, but the importance of this is that we have validated all the operational part of the engine, combustion and burning time. We've compiled lots of data. We've collected it over the years, but the behavior of engines was something that is new to us and we are already testing. And you will be in charge of developing it as well. Yes, we've actually opened a new center that will focus on all the elements of the engine. It's called LT2. Is selling engines a business? I mean, rocket engines. And just the last question. The difference with MIURA 5 will be that this will be a two-phased engine. Will you run any tests to validate this? Yes, the separation or the decoupling phases are starting to be tested. It's not on the roadmap for the moment to sell our engines to third parties. This is an internal capability. In general, all the capabilities, and I think Raul made a reference to this in this cost analysis. All of this has allowed us to see is that we have a sound supply chain, but the vertical integration process in many production elements has allowed us to reach the proper time and cost, but it is not yet in our roadmap to put all of those capabilities at the service of third parties.
I would like to ask you whether it had automatic flight emission systems in the MIURA1 or is it going to be available for MIURA 5, as you have pointed out. In this graphic, I could see a small drop that seemed to happen at the same time as the MASQ. I don't know if the PLD was able to be touched up. I wanted to ask you about the commercial capabilities. The figure you said, if this is annually or within a time range, and if with the flight data, the second model of MIURA1 can reach the 100 kilometers in height. I will begin by the first one. Well, yes, we could reach that figure. It couldn't reach much higher. Well, it was automatic, the flight control, but not as in the US. It does not consider the position to destroy the launcher. What it takes into account is the loss of communication with Earth or activation of the fatal self-failure monitoring system. It has a series of different sequences in the case that there is a critical failure at the rocket on board, but not due to trajectory. If it was going to exit trajectory, we could see this in a development with this, something that we call an automatic monitoring system that it could position in real time where the launcher was in a map. We could deploy something that I hear in the audio. IP is instant impact point. It's an ellipse within which the launcher must be. If not, the impact point is going to be outside of what we had considered previously. All of that is automatized. It has taken us a huge amount of effort, mainly being able to match it with in-time infrastructure that they use for other things, and now we had to use it for us to make it able to work with our own equipment. Safety of the trajectory was automatic. INTA said automatic trajectory, automatic tracking. It means that the radar is following the launcher automatically. The tracking was correct, that we could project the trajectory in real time and we could see whether it changed. So that's why the termination system never was launched. I think this has to do because thrust couldn't be controlled. Within that supersonic, we were within that environment of shocks. That's the point of maximum axial payload. We also have onboard measures, and we know how the structure behaved at flexion, and it behaved as we expected. From the pipeline commercial side, the 300 millions are absolute. It's not per year. It's the value of all of the offers that we have sent into the market and that the customers have said us that match in time and in time, and with all of the commercial capabilities we have, we could fill out the first 10 to 12 launchings. I don't know if there are any online questions. Yes. Yeah, I think that we have one more here in the audience. First, I would like to thank you on behalf of everyone. What you've done is incredibly difficult. You need to be in the industry to know how difficult this is. And also, I would like to thank you for positioning us on the top 10 of companies around the world that have space capacity. On behalf of everyone, my biggest congratulations and thank you so much. My second comment, I know it's difficult to answer, but an estimation for the launching of MIURA-5? MIURA-5, as we said on the slide, will be ready in 2 years at the end of 2025. We hope we could be able to show it at the end of 2025, and then we will transfer it to Kourou to be able to send in the first quarter of 2026. Our commitment is to have MIURA-5 ready in 2 years to launch it. As we said before, for a long time, we've been in the cave, not telling anyone about MIURA-5. It's much more developed than what anyone can imagine. What engine is in the process of manufacturing structure. We're very developed, and very soon you will be able to see it.
Nos llegan varias preguntas de periodistas de Teruel diciéndonos si
We have some questions from Teruel talking about or asking about how the works are going so far. Well, in Teruel, we built a new test facility to be used for testing horizontal engines and to test turbopumps that will start next week. And we will develop new 7 test banks in this area to try first and second phase engines and also to test structures for the first phase of MIURA-5. We will talk about the progress made, but throughout the upcoming year, we will develop all these structures.
la Nueva España.
José García from the Nueva España asked us whether this milestone establishes at the forefront of the space race, and if you're going to sign with any other port as French Guiana. Well, at the global scale, U.S. is in the leadership position with private companies. We're competing with other companies that are much better positioned financially, but even with funding rounds with many millions, they haven't been able to launch successfully a rocket on the first trial, and we've been able to do so. From the European perspective, we are very well positioned. We have this know-how, we have this flight experience, and we're competing with Germany mainly in this geopolitical context to be able to be first in this space race. And the other question, Maria? For us, Kourou is our first spaceport. This was an icebreaker ship. We started to promote the opening of this base for private operators. This was consolidated over the summer. We believe that this is going to be an operator multi-spaceport. We're trying to find any spaceports in developing or already working, and we hope to develop our launching capabilities in other geographical areas. Ana González from La Razón, after 1 decade of development, which difficulties have you faced in PLD Space? Well, all of them, every single one of them. Well, this is a continuous process of problem solving. And I think our main issue is funding. It's much more expensive to finance, to fund technology than to develop it. In a Starship launching, we're probably very close to one of them from SpaceX. It can cost 5 billion euros. We're not even in the last 2 digits in that process. Our funding process and the resources, we've done many things with very little. We've been very cost efficient. And from a perspective of making our company grow, from a corporate positioning project, we've funded 75 million euros. With that, we have a great team, a great position in the market, and a technology applicable for the development of a space launcher to be able to reach the orbit, which is our foundational milestone. Great. Rest of the questions, I think, have been already answered. I think Juan had another question.
Ahora te damos un slot.
Juan will give you a 10-minute slot, and you can speak with them privately to ask them anything that you want, because we're running out of time and people need to go.
No, no.
Given the commercial interest that we have now, we will be able to complete the first 12. In Kourou? At Kourou? The physical launching structures, for what you know, are going to be for several rockets, the Germans as well, or will each one of them have their own structure, so you will be invited to invest there? What economical order are we talking? The launching platform for MIURA-5 is proprietary. We are not sharing it with other operators. There are other platforms in the French Guiana projected for other companies, so it's called a specific means. I cannot give you exactly the figure, but it's around 15 millions. Thank you so much, everyone. Please stay connected. We'll have many more news.